So far, we've done a lot in terms of learning about Kotlin. So we went through and learned very basics to learn about variables, how to create a var, which is a mutable variable, and val, immutable variable. And we learned that best practice is, in essence, to always use val over var. We're able to declare variables and explicitly initializing those variables, which is a good way of thinking about showing exactly what types are we creating as we create those variables. Even though most IDEs, integrated development environments such as Android Studio, they may find certain ways that we put together these initializations redundant, but it's always important to think in those terms because that is exactly what's happening in the back end, as you see here in this example. Right? We're explicitly saying that this variable name will always be a string. Very good. And also we learned about a different way to initialize variables. So we can initialize them and give them a type, and then later on and say name is equal to James, for instance, to initialize that variable. So we declare the variable, the type, and so forth, and then we add something to that variable. Then we moved on to looking at basic types in Kotlin. So first, we divided these types into two groups. The first one is the whole numbers, so we have integers, bytes, and short. And then the second group was the floating points types, as we call those, decimal numbers, so doubles and floats. Now, for our basic ones, the whole numbers, integer, of course, is the most used, commonly used, and we have byte and short. So the idea is to always think in terms of okay, when do I use one over the other? Okay, not all of them are created equally because internally in memory, they have a certain capped size. Okay. So for floating points types, we have double and float. So the thing to remember here is that if you need precision, you will always use double because double has more space, meaning the size of a double is larger than of a float. Hence, we are able to store more decimals in a double than we can in a float. Okay. And then we looked at some basics operators such as multiplication, addition, subtraction, division, and the modulo operator. Okay, so we are set for the basics, at least to understand how these, as they call them, primitive types can work. And we can, at this point, be somewhat dangerous when it comes to understanding how Kotlin, the basics, work. Now we're going to move on to loops and branching. So we understand now how to create conditions so that we can then have some sort of a tree-like map of, okay, if this condition is true, then this will happen. If this is not true, then that will happen. Else if this other thing will happen. Okay, so create some sort of like a tree of conditions and decisions that will be responding depending on the data that we're fitting in, which essentially is how computers, programs work. Okay, let's go ahead and get started. All right, so that's what we're going to be doing next.